about class today, we're going to go ahead and cover the second section in chapter 11. It's the last section we're going to cover, and it's on series. And what a series is when you take a sequence, which we've been working with, and you take all the terms in that sequence and add them together. So here is an example. Suppose a section of an amphitheater can seat 18 people in the first row, and each row can seat 4 more people than the previous. Well, it says find the number of people who could sit in the first 5 rows. Well, what you would need to know is how many in the first, the second, the third, the fourth, and the fifth. Well, in my first row, I know there's 18. In the second row, 4 more people, so 22. In the third row, 4 more people, so 26. The fourth row, 30, and the fifth row, 34. Well, if you wanted to know how many people were sitting in all 5 rows, you'd have to add them together. So 18 plus 22 plus 26 plus 30 plus 34 is equal to, well, it's equal to, if we take out your calculator and you add them all together, you get 130 people. Okay, so when you go ahead and add all those terms together, you go ahead and you get a series, and the sum of the series is 130 people. Okay. So, time for a story. In the late 1700s, Carl Friedrich Gauss was a student in a small German schoolhouse. Gauss was a bit of a troublemaker, and the teacher was fed up. As a punishment, he made Gauss sit in a corner and add up the first 100 integers with the thought of this being a very lengthy and tedious task. Gauss finished within seconds. So Gauss was a pretty smart kid, and what he noticed was that, well, if I need to take 1 plus 2 plus 3 plus all the way up to 100, he noticed that if I take 1 plus 100, that gave me 101. If I take 2 plus 99, that gave him 101. If you take 3 and 98, 3 plus 98, every single time he was getting 101. Well, then to think about how many pairs there would be. Okay, so one pair would be 1 and 100, another pair would be 2 and 99. So he would be thinking about how many pairs he had. Well, he noticed that the sum would just be the number of numbers, 100, divided by 2, because there was 50 pairs, and every single time they were adding up to 101. So he went ahead and did this. He got 50 times 101, and what that went ahead and gave him was 5,050. So from 1 to 100, it gave him a sum. The first 100 terms, so this is notation, would be 5,050. So what we could notice is that the way he came up with the formula is if you take, well, 100, this was the number of terms, so that's my n. 1 was the first term in my series, so this would be a sub 1. And 100 was the last term, so this would be my a sub n. So he actually took note of a formula that we still use today. And you can go ahead and see that right here. That's the formula that Gauss used. So he was using the equation off to the right. But there's also another equation that we have here on the left. Okay, and they will actually both do the same thing. But one thing to know is the equation on the left uses your a sub 1 and your common difference. And the equation on the right uses your first term and your last term. Okay, so they use a little bit of different things. So let's just go ahead and look at example 2. Aiden did push-ups every day in March. He started on March 1st and increased the number of push-ups done each day by 1. He did a total of 1,085 push-ups for the month. How many push-ups did Aiden do on March 1st? Well, one thing that we would take notice is if he increased by 1 each day, so we're only increasing by 1, that's an arithmetic sequence, so we are going to sum, so it will be an arithmetic series. Okay. So what I would just take note of is, well, what is my first term? Well, on the first day, we don't know how many. That's what we want to know. So we're not sure what our first term is. We do know the common difference, though. Every day we are adding 1. And then n. Do we know how many days it is? Well, in March, there is 31 days in March. That's when my n is 1. So I would look here. Since I have my common difference, I'm going to go ahead and use the formula to the left up top here. Also, another piece of information that I know is that my sum, okay, of n is 1085. So what I need to do is I need to go ahead and plug this all into the equation off to the left. My S sub n is 1085 is equal to my n, 31, divided by 2. Then I take 2 times my a sub 1. Well, we don't know what that is, so I'll write a sub 1. So we're trying to figure out. Plus n, well, that's 31, minus 1 times our common difference of 1. And we need to go through this to figure out what n is. Sorry, not n, what a sub 1 is. So I just start simplifying. I still have 1085 is equal to 15.5. In the inside here, I see 31 minus 1 will give me 30. 30 times 1 is 30, so I have 2 a sub 1 plus 30. Then I'm going to go ahead and distribute this 15.5 to each piece here. So I have 1085 is equal to 15.5 times 2 is going to give me 31 a sub 1 plus 15.5 times 30 will give me 3,000. Sorry, 15.5 times 30 does not give me 3,000. That gives me 465. Then I would go ahead and I need to solve. Well, in order to solve this, I would subtract 4,065. 465, excuse me again. And what I would get is 620 is equal to 31a to the sub 1. And then I would go ahead and divide by 31. So a sub 1 will equal 20. So now I need to think about, well, what is this telling me? We want to know how many push-ups that he did on the first day. Well, this is my first term of my sequence. So he did 20 push-ups on the first day. Let's go ahead and look at the next one. This one is very similar to the example that we just did. So I would like you to pause the video and I would like you to do example 3 right now on your own. Okay, here would be the work. You do not know a sub 1. You do know your n is 31 because there is 31 days in August. The difference is 100 and the sum total is 1,240,000. 124,000. Okay, so you plug all that in and then I do all the algebra, and if you get to, you should get to that 2,500 is equal to a sub 1. So what this tells me is that on my first day, or their first day, they gave away $2,500. Okay, example 4 says find the sum of all positive odd integers less than 800, less than 180. So we want to go ahead and do that. I would take note that, well, how many odd numbers are there between 1 and 180? There's going to be half as many, so there's 90. My first term would be 1, and my nth term, well, is 180 odd? No, but the number below it, 179 is. So that would be my last term. Then I can go ahead. I see that I have my n, my a sub 1, and my a sub n, so I can use the formula that Gauss used. So I would have that the sum of the first 90 terms would be 90 divided by 2. Okay, so we're using this formula here. And then my first term is 1 plus 179. So this would give me 45 times 180. So there'd be 45 pairs of 180. And so my sum of my 90 positive odd integers would be 8,100. Okay. Example 5 says find the first three terms of an arithmetic sequence in which a sub 1 is negative 16, a sub n is 33, and s sub n is 68. Okay. So looking at what I am given, I have a sub 1, a sub n, and s sub n. So I can use this equation and figure out how many numbers are in my terms, in my sequence. So I have 68 is equal to n over 2, and then I have negative 16 plus 33. And I can simplify. Negative 16 plus 33 is 17. Okay. And if I take 17 divided by 2, I get 8.5n. And if I divide, I get that 8 is equal to n. Well, if I want to figure out the first three terms of the arithmetic sequence, I know that I need to know what the common difference is. So now that I have this, I'm going to use this first equation, plug in everything I know here, and this time I would be solving for D. So my S sub n is 68. My n is 8, because I just found that, 8 divided by 2. Then I have 2 times my a sub 1, which is negative 16, plus my n minus 1, so my n is 8. 8 minus 1 times the difference. Well, we don't know what the difference is. Okay, so when I start simplifying, 68 is equal to 4. 2 times negative 16 is negative 32. 8 minus 1 is 7, so plus 7d. Then I would go ahead and I would distribute the 4. So I have 68 is equal to negative 128 plus 28d. I would add 128 to both sides. 68 plus 128 is 196 is equal to 28d. I would then divide by 28. And 196 divided by 28, that will tell me that my common difference is 7. So what I need to do to answer the problem is it wants the first three terms. We know that the first term, a sub 1, is negative 16. And then in order to get the second term, we go ahead and we add 7 to it. Well, negative 16 plus 7 is negative 9. And to get my third term, I would add 7 to negative 9. I would get negative 2. So there is my first three terms. We are going to go ahead and stop the video there for today. We will finish up 6, 7, and then we'll move on to geometric series tomorrow in class. So have a good night, and I will see you tomorrow.